IDA Classification 1, Training Preparation. After logging into the IDA cockpit, a zip file can be uploaded in the IDA dashboard under Data Sets using the Upload button at the top right. This zip file should contain a folder structure with document classes as subfolders and the corresponding training documents. Two types of datasets can be uploaded via the Upload function in the IDA dashboard. First, let's look at unknown datasets. These require the Process function after uploading. This process makes the contained documents machine-readable by creating a PY file for each document, which is also stored in the folder directory. For the PDF render behavior, select the option Always Render PDF and process the files by clicking the button. This may take some time. Alternatively, a dataset that has already been processed can be uploaded. The uploaded dataset can now be renamed using the pencil icon. The delete icon next to it removes uploaded datasets from the IDA dashboard, but not from the folder directory from which it was uploaded. Among the 4 content options available for a dataset, a processed dataset now shows a DS label for document split. With this technology, similar to classification, large documents can be split into sections. To begin classification labeling must first be performed under Actions. Under Classification Label Preview, the depth of the file structure can be selected using a slider in case there are multiple levels. The result can be checked via the Selected Labels display. Now, a classification topic must be assigned, and by clicking Create Labeled Set, the classification labeling will start. Technically, this means that the document class, based on the storage location in the folder structure, is written into the PY file. This is the starting point for the AI model to train the classification. The dataset is now available for document classification, recognizable by the DC label under Dark Content. Before training can be performed, the dataset must first be split into a training and a validation dataset. This is done using the Split option under Actions. Then, in the Split strategy, an option is selected. Since we want to perform document classification, we select the option Optimize for a given DC topic. In the output configuration, the distribution between training and validation datasets can be set. The 2 subsets can then be named and created by clicking Create Split Sets. Thus, 2 subsets have been created from one dataset. Previous configurations of the dataset can be viewed and recalled under the star icon in the corner under the No Filter option. In the Detail view, the existing classes, the number of documents contained in them, and the source set under predecessor datasets can be viewed. To gain a deeper understanding of the dataset's history, the detail view of the predecessor set can also be accessed. Under the Merge option in Actions, 1 or more classes can be added to a dataset stored in the IDA dashboard. This can be helpful, for example, if certain document classes need to be retrained or supplemented. This completes the training preparation. We now switch to the Training tab on the left and click on New Training. Then, under Configure Training, we select Document Classification, then the first option, Neural DC Model, and the training dataset prepared in the first part of the video. Now, in the Expert options, in addition to the standard configuration, 2 more options can be selected, with the last one recommended for GPU use. For model size, you can choose between a default with a maximum of 255 trainable classes and a large model with 1023 classes. Additionally, the number of CPU cores to be used for training the AI model can be set. This allows the training speed to be increased at the expense of lower performance for parallel applications. Finally, there is the option to enable GPUs for training. However, no GPU is available on the test system used in this training video. By clicking Create, the training is started, and we move on to the next step, where we must assign the validation dataset, which we also prepared in the first part of the video. Below that, there is a chart in the overview that shows the accuracy of the training. The trained model is tested on the selected validation set. Below the table, you can see which dataset is assigned for this. To ensure that training works smoothly, the training dataset itself can also be used as a plausibility check in addition to the validation dataset. If the result is not approximately or exactly 100%, there is an error with the training data, and a proper model cannot be trained. The model is now trained over 40 epochs. Each epoch can be evaluated individually. For further metrics, the validation details can be viewed. The scores and precisions of the predictions made by the model will gradually increase over the next epochs. The confusion matrix shows the results of how many documents were correctly classified and where errors occurred. As seen in the vertical bar, every document is currently classified as empty label UNK because the model is not yet trained. The goal is to have a diagonal line without outliers. Then we know that the model is classifying documents correctly. Training the AI model now may take several hours to days, depending on the size of the datasets and the performance of the hardware. In the next video, we will look at how the trained model can be evaluated for quality and how it can then be released for use.